A post-tension concrete beam has a cross-section area of 100 mm by 300 mm. So the total area of concrete will be 3 into 10 power 4 mm square. It is spanning over a span of 10 meters. By successive tensioning and anchoring of the cables, cable 1 is parabolic with an eccentricity of 50 mm below centroidal axis at midspan, whereas 50 mm above centroidal axis at supports. Cable 2 is parabolic but has an eccentricity 0 at supports and 50 mm at midspan, whereas cable 3 is straight and has a constant eccentricity of 50 mm all over. We know I will be equal to BD cube by 12, that is 100 into 300 cube by 12, which will be equal to 225 into 10 power 6 mm to the power of 4. Given cross section area of each wire as 200 mm square and the initial stress is also given, that is 1200 Newton per mm square, then P will be equal to stress into area, that is 1200 into 200, which is equal to 240 kilonewtons. In cable 1, stress at supports will be equal to P by A minus PE by I into Y. Substituting, P is 240 into 10 power 3 in newtons by area is 3 into 10 power 4 minus P is 240 into 10 power 3 into eccentricity is 50 mm it supports and Y is also 50 by I is 225 into 10 power 6. So that will be equal to 5.3 Newton per mm square. Whereas stress at the center of the span will be P by A plus PE by I into Y. That will be equal to the same 240 into 10 power 3 by 3 into 10 power 4 plus 240 into 10 power 3 into 50 into 50, that is 50 square, by I is 225 into 10 power 6. So that will be equal to 10.7 Newton per mm square. Whereas in the cable 2, eccentricity at the supports is 0. So this will be 240 into 10 power 3 by 3 into 10 power 4 only P by A, which is equal to 8 Newton per mm square. Whereas cable 2 at the center of the span has an eccentricity of 50 mm. So it is 240 into 10 power 3 by 3 into 10 power 4 plus eccentricity 240 into 10 power 3 is P into eccentricity is 50 into Y is also 50 by I is 225 into 10 power 6. So this will be equal to 10.7 Newton per mm square. Average stress at supports it has some value and at midspan it is having some value. In between it is varying parabolically. So the average stress here will be the 5.3 at supports plus 2/3 of difference, that is 10.7 minus 5.3, which is equal to 8.9 Newton per mm square. Whereas here it is 8 plus 2/3 of 10.7 minus 8, which is equal to 9.8 Newton per mm square. So the loss of stress will be alpha into Fc. Alpha is given as 6, so 6 into 8.9, which is equal to 53.4 Newton per mm square. Whereas in cable 2 it is 6 into 9.8, which is 58.8 Newton per mm square. when cable 1 is tensioned, then no loss, whereas when cable 2 is tensioned, there is loss in cable 1, which is equal to, we have obtained it as 53.4 Newton per mm square. Whereas when cable 3 is tensioned, loss in cable 1 and cable 2, loss in cable 1 is 53.4 Newton per mm square and loss in cable 2 is 58.8 Newton per mm square. So the total loss in cable 1 will be 53.4 plus 53.4, that is 53.4 plus 53.4, which is equal to 106.8 Newton per mm square. Whereas in cable 2 it is 58.8 Newton per mm square, and in cable 3 there is no loss, then percentage loss will be 106.8 by the initial pre-stressing post-tensioning stress is 1200, so into 100 to convert it into percentage, so this will be equal to 8.9%, whereas here it is 58.8 by 1200 into 100, that is equal to 4.9%, and in cable 3 it is 0%.